So this is using what we did on Friday, where we use our perfect square trinomials to solve things even though they're not set equal to 0, which is okay, we can do that. So this is when we look at this piece here and we say, hey, that guy looks like a perfect square trinomial. I've got a perfect square in the front, I got a perfect square in the back, and that middle piece, that's 2 times the piece from the front and the piece from the back that was squared. So if we start to recognize these, that's great. This piece is our x squared, this piece is our 3 squared, and that middle piece is made of 2 times the x times the 3. So this is a perfect square trinomial, so we can write this as our x plus 3 squared equals 16.
16 is also.
And 16 is also perfect square. Yeah. So when I come up here and I square root both sides, because that's our next step, what do we get? X plus 3. Excellent job. Plus or minus 4, because we're square rooting both sides of an equation. So we had to put that plus or minus in there because we're going to have 2 solutions. Woohoo! We remembered that even after a weekend. Woohoo! I'm happy. Early on a Monday, levels of happy. So it's like, ooh. But that's when we split it into our 2 options. X plus 3 equals 4, and x plus 3 equals negative 4. Really actually super warm in here. So what are our solutions going to be here?
X equals 1 and x equals negative 7.
Yes, because on this one we subtract 3 from both sides, so we're going to have x equals 1. And on this side we're subtracting 3 and we get x equals negative 7. So those are our 2 solutions. Once we get the hang of it, these aren't the worst. They're not the worst. We've got worse things to happen. The bottom one, same vibe, slightly different outcome. But it's a very similar vibe, whereas this piece is not a pen. It is x squared, and 25 is made up of 5 squared.
Negative 2 times x times 5.
Yep. And the sign doesn't really matter. The sign is fine. But this is still made of 2 times x times 5. So it is, in fact, a perfect square. So we can put it into our perfect square form where we have the x in the front, the 5 in the back, and they're being subtracted. Equals 11. 11 is not a perfect square. In fact, 11 is, in fact, prime. So when we square root it, and we get our...
I'm square rooting it just because it's like 3.31.
And so since it's super gross and decimally, what do? Leave it as plus or minus square root of 11. Just leave it there.
That's our answer.
Well, we got to get x by itself.
True.
And you can either do it as 2 separate thoughts or you can do it in one. That's fine. Because we know we need to add 5 both sides. So you can put this as x equals 5 plus or minus square root of 11. That is absolutely valid. Or you can split it and do our x equals 5 plus square root of 11 and our x equals 5 minus square root of 11. Genuinely, either of those is totally fine. This is 100% acceptable as an answer. These are also 100% acceptable as an answer. It genuinely makes no difference.
Making all of the above an answer.
Oh, that would be mean to have all those as options.
Yeah.
That would be mean. I don't try it on purpose, Vicky. Okay, questions on these?
It's funny because I was watching a video
Uh-huh.
from was watching this video of a compilation of people doing the dance, one of the dances from the Great Gatsby musical,
Mhm.
and I go in the comments, and someone is like, "The Great Gatsby is a musical?"
Oh yeah.
Yeah. I mean, it is like very new.
It's a fairly new movie. I think it was up last year for Best New.
It like.
Or did it just premiere this year and it's up next year?
I think its first show was April something this year.
April's when the cutoff is for Tony's, so I think it was up for it last year,
I don't know.
but I don't remember for Tony's.
This is where we search it up.
Okay, so today we're gonna work with those perfect square trinomials a bit more. There's a whole lot of words up here. We're gonna make things be perfect squares. So the first thing we're gonna do is we're gonna figure out what piece we would need to add in order to make it be there. So you already have the perfect square trinomial pattern, but it's just written here again for us because we are going to make things be perfect squares even if they're not. Because the solving with the square roots that we did in the bell work was honestly not that awful. And so what we're going to start with is we're going to figure out what piece we need to include. Yeah? I'm very expressed about that we're going to need to include to do that. So if you do not have this pattern, you want to make sure you have that down. And then our example is actually at the very bottom, kind of on top of the flower, where it's the x squared plus 6x plus, and then there's a blank.
Oh.
And what we're going to figure out is we're going to figure out what number would we need to have there in order for it to be a perfect square trinomial. Now I'm trying to find my glasses.
The Great Gatsby was nominated, had 11 nominations.
Yeah, last year?
Yeah,
I was going to say, I thought they were up last year.
and they were legit leading the way for nominations, but they ended up only winning Best Costume Design for a musical.
The costumes were pretty epic.
And then they were also, for Outer Critics Circle Awards, I don't know what that is, they won set design.
I think that's off Broadway. I think that would be previous.
Yeah, and then Drama League Award, the person who plays Daisy is nominated for Distinguished Performance.
Awesome. We're going to back into math. What's that?
You have offset, what you say?
Uh-huh. I stay until 3:30. Every Monday. All right, so we're going to look at this one down here at the very bottom. We want this to be a perfect square so that we can use this perfect square pattern to write it like this. So what would need to be here in order for x squared plus 6x plus something to be a perfect square?
9.
How do we know that?
Because 2
Mm-hmm.
times x
2 times x times
times 3.
something would need to, that was meant to be a question mark, would need to be 6.
Yeah, it would be-
So the question mark has to equal 3. So this guy equals 3 squared, which is 9. You guys are exactly right. I was just going through the whole process of it. That's the piece we're going to be looking for today. Is we're going to figure out what piece we need to have there and why this helps. This is a process called completing the square. There are a bunch of different lists. If you are a checklist kind of person, if you like to do memorization of I do this, that, this, there's ways to do that. The way I'm trying to show you, I feel like makes it slightly more intuitive, but we're working on it. Okay, so if this is challenging today, that's okay. This is one of the hardest concepts in quadratics is completing the square. So we're going to practice this for a little bit first. We're going to figure out what this last piece needs to be to make these be perfect squares, and then we're going to write them in our perfect square form. So if I have x squared plus 10x plus something, we're going to try and figure out what c would need to be in order for it to be a perfect square, and we're going to write it in its perfect square form. So our first term is an x squared. We know that. That's something squared. C is going to be something squared. And we know whatever that is, we need to have 2 times the front, that x, times whatever that question mark is, to equal up to our 10x. So what is question mark going to be? 5, because 2 times x times equals 10x. It would have to be a 5. And that's another way of setting it up, is to say 2x times question mark equals 10x, and solve for question mark.
5 squared, 25.
Yeah. So question mark is 5, which means C, our question mark squared, has to be 25, because that's what 5 squared is. Putting this into its perfect square form, this guy, we're going to have our x in the front. That's the front piece squared. And then we actually put question mark back here. So it's going to be the 5 over here. And it always gets whatever sign is between the first 2 terms, so we get a plus. So we're adding in 25, so that plus C, adding 25 so that we can write it with this 5. So we're going to do the same thing on the right-hand one. I've got my x squared minus 8x plus C. So again, we have our x squared in the front. We know C is going to be made up of something squared. And that our 8 needs to be the same thing as 2 times x times question mark. So what's question mark going to be? 4.
Actually, oh yeah.
4.
You made it a negative 2.
What's up?
I was saying because you made it a negative 2, so
Yes. And if it works, think about it that way, where you have it as negative 4 in the question mark, that works the same way. Just make sure we're putting it into our factored form with that minus sign. All right. So our C is going to be what?
16.
C is going to be the 16. It's the question mark squared. The guy added on the end. So if I add 16 to this polynomial, if this guy's really 16, then we can write this in its perfect square form, where I have my x in the front and I have the 4 in the back, and it should be a minus 4 squared, because it uses this front, that is not the laser pointer. It uses this front sign. Or if you do like Darren does, put this as a minus 4, this then switches to a plus, so you have plus negative 4, and it winds up as the same thing. Okay? Cindy okay on that part? We're going to continue. Yes, dear.
Would it matter if you switched the numbers so if you got minus 4?
It doesn't matter. As long as you wind up with this factor form, it does not matter what order you write it in. Okay, because we're going to use this to work on solving using our square root properties like we did in the bell work with things that aren't necessarily perfect squares when we first get them. So I'm going to put up the wall of text instruction steps that the book gives us for it for a very brief second. If you are genuinely confused on the question mark and how I got C parts, there's another option for you. You can do it like this. So if you have no idea what I just did, write down this statement here. This is the steps that they give you in the book. It feels like it's overcomplicating what we just did.
It is.
So that's why I did it my way first. But if you don't like my way, which is valid, my brain is very different. And sometimes things that work for my brain do not work for everybody. So this is in your textbook. If you are a formula person and you prefer to memorize something and just be able to spit it back out, this is your go-to right here. This is your guide. But also, you don't have to use this. You can do exactly what we just did. It does the exact same thing. But I'm giving you the resource from your book because you pay for the book. So we're using it. Ta-da. And all your homework questions come from it, but still. But again, this is not a huge thing I'm going to do. It's absolutely valid, 100% works. It's just talking through it, and it's just giving you a formula for it instead of talking and thinking through it, where I prefer the talking and thinking through it. All right. There we go. So what we're going to do is this. I want to solve this guy using perfect squares. So this is going to be our first one. So what I'm going to do is I'm going to rewrite this equation, and I'm going to take that -4 and the equal 0, and I'm going to push it over to the side just so it's out of my way. As in, literally, I'm going to leave a gap. So our x squared plus 18x minus 4 equals 0. I'm going to write this as x squared plus 18x, and then I'm physically leaving an open space, minus 4 equals 0, leaving a physical space. And then what we're going to do is I want to figure out what we just did. What number needs to go here to make this be a perfect square? So ignoring this part, doing exactly what we just did on the previous two. What number needs to go here to make this be a perfect square? That would be when we would have, our x squared and our question mark squared. And the middle is made up of 2 times the x in the front times question mark. So question mark is
9.
Question mark is 9, and so we're adding on our question mark squared, which is 81. I'm just shoving him out of the way. He's in my way. I'm just scooching him away for now. We'll deal with him in a minute, but we're just going to shove him out the way. So I would really like to add an 81 here because that makes that chunk be a perfect square. We're in an equation, though. When I do something to one side of an equation, what do I have to do to the other?
The same thing.
The same thing. So if I added 81 on the left side, we're going to add 81 on the right side. So whatever we add to the left, we have to add to the right. Everyone see what I did there, even if we don't know how I did there? Okay. Even if we don't know why, that's fine. We're just seeing what we did. Because now what I'm going to do is I'm going to take this guy and say, wait a second, this guy is a perfect square trinomial. We love perfect square trinomials. Then we can write that in perfect square form. And when I do that, it's going to be my, not pink, perfect square form where we have our x in the front, our 9 in the back, and it uses the plus sign. Minus 4 equals 81. I wrote really big. Everyone see how this might be helpful now?
Oh, you still have to put your -4.
We still got that -4. He's still hanging out. We just shoved him to the side.
So he's just there.
He's just there. But now I want to solve this. What do I need to do to solve it? What will be my first step?
-4
We have to deal with the -4, but what do we do with it?
+4.
Add it to both sides. So we're going to add 4 to both sides. To isolate my square, my x plus 9 squared equals 81 plus 4 is 85. Square root both sides. I'm going to give us a little bit more space, which means I have to change the view. Give me a second. Just so you're not having it. So then we're going to square root both sides. And we get our x plus 9 equals...
Square root 85.
Square root plus or minus.
There you go. Plus or minus square root of 85. Because we square rooted both sides of an equation. And again, whatever I do to one side, do to the other. So one last step.
X minus.
So we subtract 9 from both sides. So we could write this as minus 9 plus or minus square root of 85. Totally fine. Or you could split it. X equals -9 plus square root of 85. and x equals negative 9 minus square root of 85. Which, if I wanted decimal answers, we would then go type those in the calculator, but I don't really care about that right now because we're doing the hard part. So this is our answer, or you can split it. I just was saving us some screen space and making it not molecular. Okay, so that was our very first completing the square problem. Questions? Okay, either a good sign or a good one. I was gonna say, because I always kind of adjust this around every year, trying to fit it and find the right place for it. So we're gonna do another one like this to practice. So we've got this. Our x squared minus 6x minus 82 equals 9.
So move that's 82.
Just shove him over. He's in the way, just like, boop, hip check him. Like he's walking down the hall. Oh, it happens so much. Oh my gosh. So we're going to have our x squared minus 6x, leaving a big space, minus 82 equals 9. And we want to figure out what we would like to add here, because we're also going to add it over here so that we can make this be a perfect square.
3 squared,
Mm-hmm.
9, to make it 9, add 9 on both sides.
Yeah. So our 2 times x times question mark has to be 3. So this guy is going to be, when we put it in our perfect square form, we're going to have our x minus 3 squared, which means this piece on the end has to be a 9, because 3 squared is 9. So whichever order you do it in, it does not matter. I don't see the order when you trace things down. I just get the final thing that you've written. So if you do it as the 2 times x times question mark and write that out, 100% valid. If you go, all right, well, it's going to wind up here, then I find this, that is also fine. So whatever I add to one side, I have to add to the other one. So putting this into our factor, into our completed square form, that's this guy, minus 82 equals 9 plus 9, which is 18.
Oh, I forgot about my minus 2.
Yeah, I can't forget that minus 82. Questions on that part, because that's like the hardest part of today. Okay. Optimistic, hopefully. What do we do next to solve this?
Plus 82.
Plus the 82 on both sides. That's going to give us x minus 3 squared equals 100.
And we actually have
So when we square root both sides, what do we get?
plus or minus 10.
Yeah, our x minus 3 equals plus or minus 10, because we square root both sides. And when we square root both sides, we get a plus or minus. So since I have integers, just numbers, I'm going to split it because we're going to get to actual answers. We only get to leave it with the plus or minus if it's got square roots in it. So we're going to take our x minus 3 equals 10. And our x minus 3 equals negative 10. And what are we going to get for our solutions?
Negative 7 and 13.
Negative 7 and 13. So I add 3 to both sides. So we're going to have our x equals negative 7. That's my bottom one over here. And add 3 to both sides. We get x equals 13. Boop, like that. Okay. Questions on this? Okay. Boop. That's actually it. I'm gonna pass out 3-5. I know a couple of you may have picked it up on Friday. I gave you guys the options, and you guys can do almost all of them. We're gonna do more of these tomorrow, but you can do pretty much all these. The other one we might struggle with would be 32, but you also might be able to figure it out. Okay, so this is homework 5. If you have a copy of it already, you might have a copy of it, but I know very few people say stuff on it. And you guys have some time. I was having time to work, ask questions, anything to do here, or no, And our chapter test is on the 21st, which is the Thursday before Thanksgiving break, so next Thursday. Not this Thursday, next Thursday. And it's over all our quadratics.